So we're going to continue on with our solving triangles or working with right triangles. So last class, what we talked about was we talked about this idea of Pythagorean theorem, right? If you have a right triangle and you know two of those sides of the right triangle, you're going to be able to find the third using a squared plus b squared equals c squared. So what we're going to talk about today is special right triangles. So as we start looking at some of these triangles, right? Pythagorean worked because we knew two of the sides, and we used that to find the third. So what happens when we don't have two of those sides that we know? Or we have different information, for instance, one side and one of the angles. Well, there are some situations in which this will work out really nice, and these are called special right triangles. So we have two special right triangles that we find very often when we're working through problems. And the first one is going to be a 45, 45, 90 triangle. So when we look at this 45, 45, 90 triangle, what we're saying is we have a triangle in which we know all three angles. We know this one's 90, right? And like all these triangles, they should be 90 degrees. You should always check that. The other angle is going to be 45, and then the last angle is going to be 45 as well. So as long as we have those angles, we know that the ratio in these triangles is going to be the same every single time. As a note, it says that this is ending up, it's going to end up being half a square. I like that. I mean, it's a nice note. We won't use that too much, but we will talk about the fact that this ratio is the same. So this picture up here gives you x, x, x root 2. So that's the relationship that those have. But when we're going to talk about it and we're going to use it, I'm going to end up drawing a triangle that looks like this. So this is going to be my quote unquote reference triangle that I'm going to use for all my problems. So I just took the coefficients of these, right? My 1 in front of the x, my other 1 in front of the x, and then that root 2, and I got rid of the x's. So what we're going to do is we're going to end up setting up a lot of these problems as being proportions. So hopefully from last unit, we feel pretty confident, we feel pretty comfortable using proportions because it's going to help us solve these problems given just less information than we have in the past. So I like to write down steps. I'm a steps person. So first thing we need to do is identify which special right triangle we have. So either 45, 45, 90, 30, 60, 90, or maybe it's not special, and we'll talk about that next class. We're going to draw the reference triangle next to it, set up a proportion, and then we're going to solve as well. So first one that I'm looking for here, okay? So problem A, we're going to check, just like my steps. First, I know that this is a 45, 45, 90 degree triangle. So step 2, I'm going to draw my reference triangle. So I'm going to draw a triangle that looks exactly the way that that triangle looks. So I've got my 45 here, 45 here, and then I'm going to go ahead and label in these sides. So across from 45 is a 1, across from 45 is a 1, and across from here is a root 2. Now, as a note, we will always give you those reference triangles, but I think that it helps to redraw them because then we can line them up and make the proportions a lot simpler to solve for. So I'm going to solve for an x in this case, and I'm going to solve for a y, okay? So I'm going to set up this proportion. I've got a 8 over 1 equals, and then x over 1. So hopefully this one's pretty easy to see and pretty quick to see, right? If it's across from 45, right, we have 8 over 1 equals x over 1. Well, since they both have the same thing in the denominator, the numerator should be the same. But let's double check it. Once I have this set up, I can cross multiply. I get 1x equals 8. And, you know, I don't even need to have that 1x. I know sometimes people do that and then divide by 1. You don't necessarily need that, but we end up getting that x equals 8. There we go. That's all we needed to do to solve for that one. Now, when I set up this next one, I'm going to kind of scroll a little bit lower down and do it in purple, right? I had my 8 over 1. I'm going to always use that same one. If they give you something, you should probably use it, all right? So I have my 8 over 1 equals got my hypotenuse here, my y, over root 2. And I know that that root 2 is going to be a little uncomfortable, but once we go through some of these examples, you should feel a little more comfortable using them. So just like before, I cross multiply. 1 times y just gives me y. And then on the other side, if I do 8 times root 2, you can type this in on your calculator, but we're just going to end up getting 8 root 2. So unless they're both under that radical, unless they're both under that square root symbol, you can't combine them underneath. So it's just going to be an 8 out in front times root 2. And that's how you solve for those two sides. So if you only know one side and you know the angle, you should be able to solve for these triangles. Let's try example B. I'm going to start the exact same way. Well, kind of. I'm going to draw a line over here first, just so we don't get these problems mixed up. I'm going to start by identifying it's a 45, 45, 90. I'm going to draw my reference triangle here. 45, 90, 45. And then I do a 1 across from the 45, a 1 across from the 45, and a root 2 across from the right angle. So again, that's always in the same proportion, or always in the same ratio, excuse me. Now we can go ahead and we can set this up. I'm going to solve for x, and then I'm going to solve for this one as well, it's a y. Cool. So first one I'm going to solve for is the x. I've got root 3 over 1 equals x over 1. Now again, it's not going to matter which one I put on the top or the bottom, or if my proportion looks a little bit different. The important thing is that you stay consistent. I went from right triangle to the left triangle, right triangle to the left triangle. So from here, cross multiply, I end up getting 1 times x is just x equals 1 times root 3 is root 3. Now I know we're getting into that habit of them all being the same. It might look a little different depending on the information that we have. And we'll look at some of that one of those examples when we get later on. So just be careful. Don't just automatically put the other thing. Last one. So we've already solved for x. Let's go ahead and solve for y. So again, since we already have that root 3 over 1, we're going to use that again, equals, I'm going to go back up, y over root 2. All right. And just like before, I'm going to cross multiply them. So I end up getting a 1 times y is just y over here. Now on my calculator, I'm going to type in parentheses root 3, close parentheses, times root 2. And if you notice, since those are both underneath square root symbols, you could just do the square root of 2 times 3, which is going to be root 6. All right, so hopefully once we start getting in the pattern, right, as long as you can draw that reference triangle, these problems should be pretty straightforward, right? You line them up, you set up a proportion, and you solve it just like we've done before. So again, 45, 45, 90. I've got, that is supposed to be a 45, it just looks really dumpy. So I got a 1, a root 3, or excuse me, a root 2. And then I'm going to set this up. Let's solve for my x, let's solve for my y. So I've got 4 root 5 over 1 equals x over 1. I'm going to cross multiply them. 1 times x gives me x. 1 times 4 root 5 gives me 4 root 5. And then if I'm solving for y, again, I'm going to start with the exact same proportion that I already know. 4 root 5 over 1 equals y over root 2. And then, just like we've been doing before, I'm going to cross multiply them. So I get y, because it's 1 times y, equals, now in my calculator, I'm going to type parentheses 4 root 5, close it, then multiply by root 2. Again, stuff on the outside stays on the outside, so the 4 stays there. The stuff underneath the square root symbol is going to multiply by, or you can multiply together. So 5 times 2 goes underneath as a root 10. So those are some examples of the 45, 45, 90. I think we're going to get a harder one a little bit later on. But again, as long as you follow our steps, identify, the triangle is step 1, right, as a special right, as a 45, 45, 90. Set up the appropriate reference, that's step 2. Set up your proportions, 3. Solve is step 4. Now, there's another type of special right triangle that we're going to have here as well. So it's going to be called a 30, 60, 90 triangle. And just kind of like before, remember how we said that the 45, 45, 90s were a square that's cut in half? This one's going to be an equilateral triangle that's split in half by the altitude. So just another thing to note. But our ratio here is going to be x across from our 30, a x root 3 across from my 60, and a 2x across from my 90. And I think this is the hardest part that people have, is just making sure that you put the correct thing in the correct space. Just like before as well, instead of looking at the x's with the variables and all that stuff, I'm going to have you use this more simplified version of the reference sheet, which is simply just the coefficients in front, which in this case are going to be 1, 2, and root 3. So, just like before, steps are going to be the exact same. We're just using a different reference. So, in this problem here, I'm going to start by drawing my reference, because I know it's a 30, 60, 90. I'm going to just draw that reference right below. So across from my 30, I said was a 1. Across from my 60 was going to be a root 3. And across from my right angle is going to be a 2. So I'm going to start with 2 over 1. So this 2 right here over 1 should equal, now let's set up the other one. Remember, I'm starting with the real triangle first over the reference triangle. So I'm going to do d over root 3. All right. So when I go ahead and start to solve this one, I should be able to cross multiply. D times 1 is just d equals 2 times root 3 is 2 root 3. Not so bad. If we're looking at the other one, I'm going to do it in purple. Again, we're still going to use that 2 over 1 because we already know that. And the reason I keep saying this over and over again is, say for instance, you ended up using 2 root 3 over 3 as your next one. Well, what if you had gotten 2 root 3 wrong? Say maybe you missed a step or made a mistake. Well, then your next problem is for sure going to be wrong because you've used the wrong number. So by staying consistent and using the one that you already know, it's going to help you be more accurate. So even if you miss the first, there's still a chance you can get the second. So we've got the regular triangle over the reference triangle equals regular triangle, or the one we're trying to solve for, e over my reference triangle, which is 2. And then from here, I can cross multiply. E times 1 is going to give me e. 2 times 2 gives me 4. And I've just solved for the 2 missing sides of that triangle. Awesome. Let's try the next one. And this one's going to be slightly different than the one before it. Because, if you notice, in the first one, we knew the value that was across from the 30-degree angle, right? This time, we know the value that's across from the 90-degree angle. It's going to change just a little bit how we look at this problem, but I don't think it's going to make it any more difficult. So, first step, I identified it is a 30, 60, 90. So I will draw my reference in. On my 30, I could put the 60, but remember if we know 2 angles in a triangle, we automatically know the third. So if you only want to put 1, you can. Across from my 30 goes a 1. Across from my 60 goes a root 3. And across from my 90 goes a 2. So let's go ahead and set up our proportions. So I've got my regular triangle up on the top is a 6 over my reference, which is a 2, equals, and let's solve for x first, because I think it's harder. All right, we've got our x on the top over root 3. And again, this one's going to be slightly harder because as opposed to all the other ones, this one might actually take 2 steps. When I go here to cross multiply, I've got 2 times x, which is 2x, equals 6 times root 3, which is 6 root 3. Now when I go ahead and I divide by 2 on both sides to get x by itself, all right, I can type that into the calculator, right? I could type in 6 root 3, 6 root 3 over 2. I could also look to say, hey, that 2 is not underneath the radical. That 6 is not underneath the radical. Since those are like, we can do 6 divided by 2 and get x equals 3 root 3. Again, I'm not saying that you have to do these all by hand. I would encourage you to use the calculator just to make sure you don't make a mistake, but it's nice to know the math as well. Now that we've gotten that one, let's go back. I'm going to do orange, and we're going to do our next proportion. So again, using the same one we used before, so 6 over 2 equals, and then we got the top triangle, y over 1. I can go ahead, I can cross multiply. 2 times y is 2y equals 1 times 6 gives me 6. Divide by 2, I end up getting that y equals 3. Last but not least, this one might be the quote-unquote trickiest, and the reason for that is it looks like we're using the side across from the 60. Well, we are using the side across from the 60, but it's got that square root, that radical in it, and I know people tend not to like that very much. So I think that's the only quote-unquote tricky part about this problem. But again, it is nothing, let's use lime green, nothing we can't handle. So first, I've identified it is a 30, 60, 90. I'm drawing in my reference here to look exactly like the triangle that I'm using. And then I label a 1, I label a root 3, and I label a 2. Again, we will provide that information always, but I want you to get in the habit of redrawing it. Then let's set up our proportions. So we've got 8 root 3 over root 3 equals, and then let's solve for y first. So left triangle, ooh, that doesn't look like a y, there we go, over my reference triangle. So I'm going to start first step, I'm going to cross multiply. So I get y root 3 equals 8 root 3. And if I want to get y by itself, I'm going to divide by root 3 on both sides. Now again, this is something that people don't like to do a lot, but we could, one, type this in on the calculator, right? And do 8 root 3 over root 3 and divide that. Or if we look here, if I have a root 3 divided by root 3, if I divide something by itself, it cancels. So I'm just left with y equals 8. Not too terrible. And then the last one that we have, again, we're going to start using the information that we know, and I'm going to kind of run out of room a little bit here, unfortunately. Let's use black, all right? So we're going to start with the reference that we knew from before. I'm going to erase the other problem just because I'm running out of room. All right, so we have 8 root 3 over root 3. Remember, use the same one that we're always going to use. Equals, and we're going to set the next one up, x over 2. I'm going to start by cross multiplying. So I get x root 3 equals, well, 2 times 8 is 16 root 3. And then I'm going to get x by itself. So divide root 3 on both sides. They cancel here. They cancel here. X equals 16. So while using this, square root symbol, root 2, root 3, depending on the situation, while that can be a little bit uncomfortable, a lot of the stuff that we're doing in this lesson is just an extension of what we've already done, right? We are able to draw a right triangle and label it. We're able to set up a proportion. We're able to cross multiply and solve. It just looks slightly different, the situation that we have, but this is all things that we've done before. The last thing I want to do is look at 2 more examples. And this is the reason why. In these examples, I'm not telling you which special right triangle they are. We're gonna have to start and figure that out on our own and apply the proper reference. And I think that's one of the hardest parts about this is identifying your triangle and then knowing which reference triangle you're going to use. So in this triangle, I'm looking over here. I see a 30, 60, 90. So I'm going to draw my reference right down here. And I've got my 30, I've got my 60 up here. And then, oh shoot. I can't remember what that reference triangle looks like. I'm going to go up here. Oh, right, the 1 is across from 30, and the root 3 is across from the 60. Okay. So we've got the 1 across from the 30, the root 3 across from the 60, and then we've got this 2 across from the 90. Now I can go ahead, I can set up my proportions, and I can solve this. So the 4 lines up with the root 3. It's a terrible root 3. And then let's solve for f first. I've got my f over 1. Let's start by cross multiplying. So I've got f root 3 equals 4. And this is definitely a weirder one. This is something we have not seen before. So when I divide by root 3 here, again, I would encourage you to use the calculator on this one. That's what I'm doing right now. You just can't see it, but I'm using it. 4 divided by root 3 is going to give me 4 root 3 over 3. Ooh, that's a terrible 4. And I think this is another thing that gets people kind of confused is, yeah, 4 root 3 over 3, that's really weird. And like part of me wants to go, that's wrong because it looks so weird. But you did everything correctly. You got the right answer. If I were to look at this as a decimal answer, it's somewhere in the 2.31 area. But that's actually going to end up being your correct answer. So don't worry if your answers are a little odder looking. As long as you do the process right, you're going to be right. So I got that first one. Now I'm going to use the same thing. 4 root 3 equals, and I've got g over 2. I'm going to start by cross multiplying. So I end up getting 8 equals g root 3. Man, these 3's are tripping me up today. Divide by root 3 on both sides because I want to get g by itself. And just like before, we're going to end up getting 8 root 3 over 3 equals g. And that's going to be your answer. That's going to be that third side of that triangle. So again, you can get slightly weirder answers. That's fine. As long as you follow the process, you're going to be okay. Last but not least, let's try this one as well. First step, we should identify the triangle. It is a 45, 45, 90 triangle. All right, and it has been probably a good couple minutes since we've seen that, so I'm going to scroll all the way to the top. Okay, so I got a 1 across from the 45, a 1 across from the 45, and then a root 2. So we got a 1, 1, root 2. We're going to go ahead and we're going to solve this. We got an x here, we got a y here. So first one I'm going to do is 24 over root 2 equals x over 1. Let's solve for x first. I cross multiply. I get x root 2 equals 24. And then just like we did in the other problem, I would encourage you to type this in on your calculator when we end up dividing by root 2. And you'll end up getting that x equals 12 root 2. And if you're very curious and you're like, wow, that's kind of interesting and you want to know more, again, you can always ask Mr. Fife or myself or Ms. Grabowski, and we can always help out and explain it a little bit more. Last but not least, we're going to do the other side, which is 24 over root 2 equals y over 1. Hey, look at that. It looks pretty much the same as the proportion I just set up. I cross multiply, I get y times root 2 equals 24. It is the exact same one. So when I divide by root 2, I should end up getting that y equals 12 root 2. And that makes sense because my sides opposite these angles, since it's the same angle, should be the same side. So hopefully this gives you a little, a good understanding of how to identify these special right triangles, how to set up the reference, and how to use them. So again, if you have any questions while you're going through this, please let us know. Feel free, jump on. We have office hours every single time during our class period. So go ahead, stop on in, ask questions, and we'll solve them best we can. Have a good one.